All right, so homework 7.1. Remember, we're talking about rates and movement. Let's go ahead and put your name on it now. And your period number. I'm currently in 3/4. Your name should be on your homework. Let's go.
Dude, leave my headphone alone.
All right, so now that everyone's settled down, let's go ahead and recap real quick from the day. We're talking about distance from the motion detector on my y-axis. We're talking about time passed in seconds on my y-axis. When my line is flat, I'm not moving. When my line is going up really, really steeply, I'm moving away from the motion detector very, very quickly. Remember, if I start at 5 feet away from the motion detector and move 6 feet away, then 7 feet away, then 8 feet away, then 9 feet away, I'm getting away from. The steeper your line, the faster you're going. The closer to a flat line, the slower you're going. You're still moving away because look, at here you were 9 feet away, now you're 10 feet away. So you're still moving away from it, it's just taking you a lot more seconds to get there. Then again, flat line again, you're not moving at all. Now let's take a look here. All of a sudden I was 10 feet away, now I'm 9 feet away, now I'm 8 feet away, 7 feet away, 6 feet away, 5 feet away. So when my graph is going down, that means I'm going back towards the motion detector. So that means I'm going back towards the motion detector. Okay? Now, when do I get back to the motion detector? When your distance from the motion detector is 0, you're touching that motion detector. So whatever my seconds is here means I'm back. That's how long it took me to get back to the motion detector. Remember also that rate is equal to speed is equal to slope. So rate, speed, and slope all equal the same thing. Another quick review. Slope is always has the word per in it when we say it out loud. So slope is always your y variable per your x variable. So it's your y variable per your x variable. So my y variable here is distance, and my x variable is time in seconds. So it'd be distance per second, or feet per second. Another way to say that is your dependent variable per your independent variable. Someone in my 3rd and 4th period class also made a great observation that per in English means a slash in algebra. So if I read this from the paper, I can say miles per hour. All right, now that we have reviewed, let's see if we can do this. For each description, okay, sorry, I forgot to read the directions. Match each description in questions 1 and 2 with the corresponding graph. Then answer question 3. So for each description of the skateboarder's motion, write the letter of the corresponding graph. So we have A, Malik. So this guy, A and B both start at the same distance from the motion detector. B moves a little bit slower than A, but they both start at the same distance away from the motion detector. C, D, and E all start at the same distance, probably like 1, maybe 2. C goes the fastest. D looks like it goes pretty slow. Now look at E. E is flat as a board, so that guy's not moving at all. Knowing that, assessing that situation ahead of time before we read the descriptions will help us as we match these up. So let's read the first one. Terrence started at 2 feet and skated quickly away from the motion detector. Well, I don't know if this is 2 feet or if this is 2 feet. So let's take a look at the others. This started at 2, started at 2, started at 5, started at 2, started at 5. So my 2 5s are probably going to match up with these two. My 3 2s, 1, 2, 3 2s, are going to match up with these 3. So that helps us right there. If he started at 2 feet and skated quickly away, so 2 feet, it's got to be one of these three, and he skated quickly away. Well, that's got to be C. He started at 2 feet and skated slowly away. So 2 feet, he's going slow. There's D. Started at 5 feet, so he's one of these guys, and skated quickly away. So started at 5, goes fast, that's A. We're back to the 2s here. And he paused to catch a breath. So which means he didn't move at all. He paused. He stopped. He needs to catch his breath. So that's got to be E. He started at 5 feet and skated slowly away. So 5 feet, slowly away, you've got B. Notice that all of these are going up at some point, so you're moving away, except for obviously that one. Now let's take a look at section 2. For each description of the skater's motion, write the letter of the corresponding graph. So same directions. Before we even read the descriptions, let's take a look over here. We've got 2 starting from pretty far away, and we've got 2 starting from maybe midway, we'll say. Well, let's see. Who's closer to flat here, F or G?
G.
Ooh, wait, here's a flat line. Whoops. Here's a flat line. Which one's closer to flat?
F.
So F. F is closer to flat, so he's the slower one. And here's the faster one. H is almost flat, so he's the slow guy. Make a note that flat equals slow. I's going down pretty quickly, so it's fast. Now notice that my distance from the motion detector is all getting lower, which means if my distance is getting smaller, I'm getting closer and closer to it. So let's try these. I've got start at 6, 6, 3, and 3. So we know this guy's 6 and this guy's 3. If we start at 6, one of these guys, and skated slowly toward the motion detector, we've got F. If we started at 6 feet and went faster, we've got G. At 3 feet, we skated quickly toward the motion detector. 3, fast, we've got I. 3 feet away and skated slowly. Slow's closer to flat, so you got H. Notice that before I even tried to attempt the question, I stopped and took a look at my graph and kind of pre-assessed what was going on. Very good. That is called metacognition. Remember, if you use metacognition, you are 30% more likely to answer the right question. To answer with the correct answer, sorry. Metacognition, you're 30% more likely to get the right answer. All right, we're being distracted, so I'll do that on the second video.